Okay, so we're getting ready to actually start talking about, well, actually, we're getting ready to write code. But before we write the code, we should stop and look at basically how do we set this up here as far as um, how we actually get this in 4-bit mode. So again, if you scroll through this data sheet, there's a lot of things going on in here. Um, and you have to keep reading through it, scrolling through it. Okay, so let's first, even though this is 8-bit operation, we're going to look here at file they do selects 2-line display and 5x8 dot character font here. So there's this 111 going on here, and this is under the function set. And we're going to scroll back up in a second to get to that, to understand how the function set works. This is how we do a 4-bit interface startup here. So 4-bit interface. First we power on the device, and then we wait for more than 15 milliseconds after VCC rises to 4.5 volts. Wait for more than 40 milliseconds after VCC rises to 2.7 volts. So technically you should be able to run this on 3.3, but I've noticed that the brightness doesn't tend to be as good here. And then it says, okay, do this command here. So we're going to write this nibble here. So it would basically, we're going to write that, wait for 4.1 milliseconds. We're going to write it again, wait for another 100 microseconds. And then write it again here. And then here is where the function set comes in. Set interface to 4 bits long. Specify the number of lines and character font. So N and F are the number of lines and character font. And character font refers to the either a 5x8 or a 5x10. And it's going to be 0 for us because we're on a 5x8. Again, 5x10 is only for some very kind of specialized one-line displays. And then basically it's saying display off, display clear, and entry mode set are the commands. Well, here is, table's not getting me. Here is the display off command right here, because this is the bit for display, and then this is having it be off. This is where it's to, remember you're writing in nibbles. So if you want to think, these are the first 4 zeros up here, and then 1, 0, 0, 0. So this is, if you want to think about it, 7, 6, 5, 4, 3, 2, 1, 0, as far as the bit positions, because we're writing in nibbles. And then here is function, the display clear. So 0, 0, 0, 0, 0, 0, 0, 1. Okay, so that gets us the clear display. And then here is we're setting entry mode set. And that entry mode set, if you read through the data sheet, that's basically, are you going from left to right, right to left, so on and so on. Okay, so that's what we're going to have to do for our initialization here. So we want to think about what we're going to need as far as, first off, macros, and then also as far as functions go. So let's just go ahead and put in the comments here some of the functions we're going to need. So, and these are all going to start with LCD. I'm just not going to bother with it at this point. We should probably have some initialization command. And this is going to maybe contain like number of lines, I2C address, number of columns, maybe, and font size. It's not necessarily going to be in this order, but I'm just thinking, okay, what are some things that I need to set in an initialization command? And so this will, the initialization will initialize all global variables for us. It's not actually going to start it up. It's just initializing all the global variables. Because we're going to have a global variable for the display control. We're going to have a global variable for entry set, so on and so on. And that's where we're going to have to do that bit masking to do those things here. Okay, so initialize all my global variables. And then after initializing all my global variables, I'm going to need a start command. That's going to be void. That's going to, of course, start the LCD screen. We're going to want to be able to print to the LCD screen. And what I'd like to have here is just text. I don't want to have to print a single character. I'd like to be able to put a string in there where I could put like, you know, hello world or something like that and just print this. Now, one thing that you might not think of that we're going to definitely need here is a set cursor position. And the reason we have to set a cursor position is by default, it's not going to just move to the next line when it gets to the end of 16 characters. It actually doesn't move to the next line until it hits 40 characters. I don't know exactly the reason why it's 40. I'm sure we could look it up. And so set cursor position. So that's pretty obvious as far as what it does, but clearly what we should do is have, you know, we're going to have to provide row and column information in order to tell it where to set the cursor position. Other things here, well, you know, display on, display off. These are going to be separate commands, just easy ones here. You know, blink on, blink off, cursor on, cursor off. So we'll start with this list here. There is a lot more that we could do and we will do with these functions here, but we'll start with this list here of the functions that we want to do for this here. So the first thing actually that's the most challenging one to do here is the start. Once you successfully start, all of these other commands are pretty easy. And we'll do all of these commands. Oh, there are some other things we need to get in here. We should do an LCD command, right byte, because we need to split, and here is maybe the data. We'll store the data in here because we need to split into nibbles and write the nibbles. Remember, we have to, so that's not necessarily going to be one that we're going to use externally a lot. You know, that's not something that the user is going to use pretty often, but we should write a function because we're going to have to write a lot of data to the screen. So instead of having to do in every single function, because, you know, this blink on is going to have a write command, this display on is going to have a write command, display off a write command, the blink on, blink off, they're all going to have write commands. And so instead of repeating all that code on how to split a byte into a nibble, into two nibbles and write those two nibbles, why don't we just come up with an LCD write byte? And in fact, why don't we even do one thing else here? Why don't we do an LCD write nibble? And I'll say nibble in here. writes a nibble using the enable pulsing. Because remember, we have to pulse that enable in order to write the nibble. So that way, what we can do with the LCD write is we take that byte, split it into 2 nibbles, and then just call the Right Nibble command that will then write that nibble. And then inside the Right Nibble command, we will have the code for writing the nibble. Okay, so that's what we're going to go with for here. So we definitely have quite a ways to go here. This is, I think, pretty short. Yeah, it is. We're only about 10.5 minutes here. But this is where I'm going to go ahead and stop because we do have quite a bit of other things going on here. So, yeah, so we have quite a bit of other stuff going on, and we're going to still take several videos to get all the way there. But this kind of gives us a starting point, and I take so much time going through here because, again, this is not something I just did and sat down and just quickly did. I spent hours and hours and hours of just reading the data sheet. Then I spent more hours coming up with the API for it. Okay?